Hello, everybody. Welcome back. Thanks for those of you that showed up on time. We're a couple minutes behind because we were talking about some things, but we are in our last day here in week 6, where we are going to talk about version control systems and collaborative coding. So, what we've done up to now is the whole thing. We wrote the app. We've finished developing the CRUD operations and our basic website with some navigation that we can take and now build further and go do some things. This version control system, the reason we talk about this now is it's a way to save that work if you want to be able to do this sort of thing both professionally and just for your own small projects, wherever you sit on that spectrum of people that want to be able to use code. A version control system is going to be very handy for developing. But for the collaborative aspect, it's a requirement for working with other people. So this that we're going to cover today is absolutely relevant for professional skill development and for people that are not looking to be a coder for a profession. I just want to use this as something to do. It's really useful to know. So before we dive into those specifics, let's review what we've done since this is the end of the course. This is what we promised to do at the beginning. So let's run through these and see if we've done these. I guess the first one we really can't assess because it's the same thing as a coding boot camp. You'd have to go do a coding boot camp that is paid to really righteously compare. So if you haven't done one already, I still don't encourage anyone to pay for it if you can avoid it. There's lots of ways to get these things subsidized for veterans, if not totally free. There are other free courses and things out there. There's lots of ways to get the information on your own if you have some discipline in an internet connection and that free set of resources we sent. There's plenty out there, but please do other training outside of this. This is definitely not going to be enough. And let us know. Let us know what you think. Say, hey, yeah, I took a coding bootcamp that was paid and it was way better. You guys are trash. I love the feedback, so keep it coming. The tangible objective, like I said, we definitely did build this fully functioning web app. I know some of the folks that are live on the call here have. I know some people that have just been able to watch the videos and are doing it at a slightly different pace have still been able to build up to the points that we did at the checkpoints. And even if you're behind, if you're watching this, this is, again, the last day. But I do want to hammer home and reiterate that you're not done. You're not out of here, right? We're not kicking anybody out of the Discord channel as long as you don't do anything appropriate, which nobody has yet. So just, keep behaving yourselves. But the intangible objectives, again, this is going to be the part that I rely on all of you to tell us with the feedback we're going to send out afterwards with the recording of today's class. We hope to demystify code and give you the tools to build anything, right? So show you where the tools are, the materials, how to use them, how to put it together in a concrete and tangible way, and then give you references to go back and look at again and again as you need to. Because again, these videos will be available in the Discord channel until we start our next class, which is going to be April 15th. So we're going to move those into our archive, which is just on YouTube, so you can still access them there. You'll still have access to all the files and anything like that. If you lose something, just reach out to us. We'll send you another copy and of the link. And you're welcome to attend a class in the future. If you want to come back and just do this class again, April 15th, you're all welcome to come back. So this is what we intended to do. And we, as far as we could tell, we've hit these things. But again, we need your feedback to know for sure if we hit, especially the intangible objectives. So when we send out our feedback forms, please let us know what you think. And again, what we covered more specifically by week, we started with the foundations of programming, how computers even understand what we're doing, what programming languages are, where they fit in, how to understand the kind of difference between, or the choice we're always making between human readability and machine readability. We talked about algorithms and data structures in the second week, where we talked about the different ways we can arrange our data, the choices that we make, why we make choices, how we assess what the best choice is, and how it's all context-based. But there are actual ways to measure performance based on, we talked about big O notation and different algorithms that are named and useful for certain tasks and certain things that you may want to do. And then we built our app for the remainder of the time, right? We walked through the create, read, update, and delete functions. We talked about databases. We talked about HTTP, how things work, moving around. And now we're going to do the advanced topics after we finished that app and talk about version control. But I do really want to highlight that the app that we built, you could take that and go into starting with the views and expand that in any way that you like. Call out to APIs, write your own algorithms, make it do something more interesting with that input information, right? You could take somebody's input, chop it up, and go look up their address or whatever you may want to do. Send an order to DoorDash and make a food delivery app or something like that. And that you have all the basic parts to get going with that. So with that, if you have questions about any of those things, please bring them up as we go. But we're going to shift gears into version control systems, because now that we have that app built, we have it at a basic starting point. What we want to do is to be able to save that whole thing in its entirety And if you want to go in and expand on it and build something more complicated, you may want to collaborate with other people, right? So that's what version control systems are good for. They're good for saving entire projects and working with other people. So before we talk about version control systems, let's talk about versions, what they are, what we mean when we talk about versions, what different kind of versions you may run into of things. Generally speaking, you've probably already seen, this shouldn't be new to anybody now, the version 3.0 or 1.5 or whatever. That is called semantic versioning. If you haven't heard the term, semantic just meaning that it has meaning of some sort. It's one of the things that us language nerds really like to use and talk about. But in this sense, it means that each one of these pieces, the first number being the major version, the second number after that being a minor version, and the patch version, each one of those numbers has a meaning based on the place that it's in. So the major versions are usually the ones that have new features, and they're not what's considered backwards compatible. So when we talked about Python, we talked about 3.10 is the one that's in Python Anywhere. When I started coding, it was, Python 2 was the version that was there, and Python 3 came out shortly after, and you would still see versions 2 and 3 around, and they do not work with each other. So you'd have to do a lot of things to handle version 2 that was still floating around because they're not backwards compatible. A version 3, doesn't matter what other version you have, will not work with the older versions. Whereas a minor version, like a 3.10, like we've been using now, should work with a 3.2, with 3.7, any of those things. It largely will be backwards compatible, but it may also include some new features. So it may not be 100%. You may run into problems with some packages. Some things may not work the same, but generally they will work. And then the patch, last number, no new features usually, mostly just bug fixes, and they're almost always backwards compatible. So like, 3.10.27 will work with 3.10.1 and so forth. The other thing that you may hear frequently in reference to versions is steps in the development process. So there are many steps that could be. These 4 are kind of the typical ones that you'll run into. There's the development phase or version of the code. That's the version that people are experimenting with. That's the version that you may have on your personal device and whatnot if you're working on a team. That's the one that nobody accesses, again, experimental features and whatnot. And then once those features have been built to a certain point and they're ready to be tested, it'll move into another version of the code where it's testing version. And development may continue. There may be another team. Like think about a big organization doing this. You may have versions of your code in all these places. Again, when I say versions of code, I'm talking about all of the files and everything that we have included. So there's a version in development, there's a version in testing. Staging would be something that's very close to a live version that everyone can access, but it's somehow partitioned off from the public. So if we're talking about a web app, it would be on the web somewhere. It would be like so it can go through the HTTP interactions, hit databases, go through servers, test your networks, do all the things in quote unquote live fire exercise without having live traffic open to the public. So it'll be somehow restricted, but it'll be close to what's called the production environment, which is the publicly accessible to whatever extent you want it to be, the final published, ready to go version. So these are the ways that you're going to see version discussed and talked about and, generally referenced, right? Now the semantic versioning, again, as a note, this major minor patch, that's not hard and fast. There's all kinds of variations to that. It doesn't have to be those 3. It could be 2. There could be other things added to it. But this is kind of a real common way to talk about them and see them. Any questions on that? Again, shouldn't be super news to anybody, but just in case. Cool. All right, so version control systems. Now we talk about what versions are. A control system is a way of tracking changes made to files and directories. That's literally all it's doing. So a version control system will be set up in a directory system, and it will track every change that's made within that system. Any file that's added, it'll track that. Any file that's changed within there, it'll track that. That's what it does. So it's kind of like a save at the project level almost. There's all kinds of different version control systems. This can be done in a number of different ways. This isn't super important that we understand the differences here that we're going to talk about, but I do kind of want to explain that it's progressed quite a distance and what is popular now and what is used now. So sort of the original versions of version control systems were local ones, or what they call RCS. And these things were pretty rigid, and they didn't make it possible to share, but it was a way to save your work. Then they came up with a centralized version control system, which worked pretty well, but it didn't allow people on big teams to work at the same time on a set of code. So then distributed version control systems are ones that developed after that, are the ones that become popular and are commonly used now. So these distributed version control systems, again, it's not real important you know all these terms or anything, but I wanted to talk about it specifically because distributed means that, again, think about a huge company like, I don't know, YouTube, doesn't matter, Facebook, any of these gigantic companies that have a website and apps and all kinds of stuff built in, and they got mobile apps and things like that. Distributed means that all their teams working around the world can work on the code base. They can get parts of it, they can work together, they can work at the same time and not collide with each other. And that's what distributed version control systems allow it to do. So it's a really big leap in the ability of teams to work together. So distributed version control systems are the ones that you're going to run into most often. The most popular one by far is called Git, Git, which stands for Global Information Tracker, which again, because it's just tracking changes made to files and directories. And it's global in the sense that we don't want to think of this as being inside of a virtual environment or specified in a particular place. It could track anything at the project level. It could track anything at the system level if you wanted to. It will track literally everything in the directory system, right? So this particular one is not the only one that exists, but it's very, 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 very popular. It's by far the industry standard. You'll see it on job applications. They'll expect you to know Git, be familiar with Git, ask you about Git, and that's what we're going to talk about today. Very, very, very commonly used. It is a distributed version control system. So again, this allows people to work in large teams on a particular code base altogether. So why? Why would we do this? Again, keeping in mind what it is that we're doing. We're tracking changes made to files and directories, but we're doing this so that we can develop and make changes and play around with things without destroying or upsetting the main code base and keeping it working. So we've been using the analogy of a physical building. Let's think about the physical building again. Let's say we've built it to a point, it's our app again, we've got it done and we opened it. People can walk in. It's now serving traffic. There are human beings walking in and out of our building. And we want to keep that open. But we realized that we didn't make it wheelchair accessible, for example. We didn't put a ramp in there. We didn't put enough accessibility features. So we want to make changes to it. What a version control system allows us to do is, if you think about that building, it's like taking we've talked about the space, physical space in it. Now we're adding the element of time, where we could take a snapshot of how that project, the whole building in this plot of land looks at a specific time and make a full copy of that building some other place where people can't get to it and they're not walking into it. So think of it like a separate plot of land that operates totally independently of the version that we completed. And we can add our wheelchair ramps and larger doors and all the things that we need to do to make it work the way we need it to make it more accessible, for example, and test it out. And then we can merge it back in with the main building. And then all the changes that we had will be present in the main building. And while we're doing the work, we don't have to close our building. It's like being able to do construction without closing the building. Does that make some sense? Or did that just confuse people? Right? Nice. Right. So then one of the reasons that you would use one of these things is to be able to do that. And you can back up your source code in cloud providers like GitHub, which we'll talk about in a minute. Make sure you got the right version of the code, with all the things that we talked about. Collaborate with other developers, hit on that a few times. Managing projects of all sizes. Again, this is not just for huge companies. It's important to know that this is used by huge companies, but I use this in absolutely every project. Doesn't matter even if you're doing small scripts that are just cleaning up files on your hard drive or something like that. It's good to use this sort of thing to keep track of changes that you make, keep versions, to make sure you don't break whatever it is you develop, and you can make it more complex as it goes. But it can do really cool stuff for larger organizations, like a continuous integration or continuous development, often referred to as CI/CD pipeline. And we're not going to do that. We're not going to set one of these things up. But the idea here is if you think about the version in the sense of development, testing, staging, and production, in a really big project, at these really big organizations, they set up as much automation as possible to move the code through those phases so that developers can develop and then they can push it to testing. And then there are automated parts that once it passes testing, it moves into staging. And once it passes test there, it can move into production. So no one has to physically go in there and do that. Version control systems are a tool that allows that big process to happen. So understanding how they work and how to use them is really important to working on projects of all different sizes and doing really cool stuff that's only relevant to big projects like CI/CD pipelines. Any questions about those things? I know some of you actually have experience with this end of it already, so I know some of this may not be news. Right. I did want to highlight one thing that as we're doing this and we're talking about Git as a global information tracker. This is tracking again changes made to files and directories. So this is not the same as when we talked about the CDN and the content delivery network. This is pulling down like the whole like the entire project to be able to work on the actual code base. So it's tracking absolutely everything that's in it. And when we say in it, the terms that we talk about in Git and the one we're going to use, we talk about things in terms of repositories. So we put things into a Git repository, and all the things that are in that repository are tracked. Or any changes once we set up a repository are going to be tracked. So changes to files, directories, subdirectories, subfiles, all of it will be tracked by this thing, unless we tell it to ignore things, which we'll talk about soon. But again, doing this in a repository locally, which we'll do first in our own machine, allows you to do storage in a cloud provider like GitHub, which is the one we're going to use later, but you don't have to use that. And the name Git in there does not mean that it's tied to the technology itself. There are lots of cloud providers. There's GitLab, there's Bitbucket, OneDev, all these other ones. It goes on and on. There are tons of these things. Git itself is a standalone technology. You don't need to be signed up for any of these. I did suggest as pre-work to sign up for GitHub if you hadn't, because it is a good thing to have, and we are going to use it at the end of class today as optional. You don't have to, because Python Anywhere has Git in it, and Git is something you can run on your own machine without signing up for any of these. So I want to be really clear that things like GitHub and GitLab, they have Git in the title, but that's kind of a marketing trick. It's not. Git is a separate thing altogether. Everybody tracking? All right. Nice. So that should be it for the slides. Let's get out of here, and we're going to go over to the free coding resources and go down to our version control side over here on the left-hand side. I'm going to go to my version control section, and it's just Git that's in here. Again, there's lots of these, but this is the only one that we're really going to talk about. There's no need to know a ton of them. If you're good with this one, you're solid. So it's got information on where to go. It's got a GitHub itself, but then there's also this cheat sheet, which I'm going to go through now because it's awesome. And it's a really, really, really good, useful guide for when you're getting going with this. And like it says, there's no deep shit. This can get very deep very, very quickly. Git can be very complicated. But this does a very good job of breaking it down. And I came back here all the time until this became habit for me. And even at that, I'd come back every now and then and double check on what the process is. So let's go through this real quick and explain what Git is doing before we get hands-on with it, so we understand conceptually the actual mechanics. I'm going to skip past the setup part because, again, it's already set up in Python Anywhere. But if you want to set this up on your own machine, this is where you would get information on how to do that. We're going to do this creating a new repository step, right? Again, the term repository means the place that we're storing things. We'll show about where that goes. But I'm going to slide down real fast, past this checking out, to this workflow section, because it has a good diagram of exactly what it is we're doing here. So over here on the left-hand side, there's this little picture that says working directory. So the working directory, we've already talked about this when we're in our consoles and we type pwd, print working directory. It shows the directory we are in, right? That's your working directory. That, in our case, project context-wise, that'll be our my site top-level project directory, right? Where you're starting your day. When we start our working day, that's where we go. So that's what working directory is. And this is where you're making changes, you're doing things. You're adding CRUD operations, or you're adding cool APIs to do whatever it is you're doing in your working directory. And once you develop to a point that you want to save it and you want to make, save your changes, you do what's called adding. And it's going to move all those changes into this staging area called index. So this is a place where all the changes you have made are listed. You can look at them, see that they are the changes you want to make, decide which ones you want to save, which is called committing, and you're going to commit a snapshot to your timeline, basically, of the code at that moment. It doesn't have to be working. You can commit broken code. There's nothing in here that's going to check to see if your code works. You have to do that on your own. But committing is when you make a save to it, and the head is where it's like now in this timeline. This is something, again, we're adding the element of time to our project. You can think of head as like the now of your project, whatever now means for you, right? So if it's a production version, the head is going to be the latest code of that. So the latest committed code is where your head is. Does this make sense? Everybody understanding this? I also want to highlight, before we go further, that this terminology, although new, with add and commit and things like that, It is not entirely different than what we've already done when we did our databases in our backend development week, when we added our own custom database definition, and we did make migrations, and then we did migrate. So make migrations is like add. And then remember, we looked at the make migrations output in Django, and it said these are the things that we're going to change. And we can go in there and look at it. If that's right and we're good, then we run migrate, and it commits our changes to the database. So this process of adding, checking it out in a staging environment of some sort, and then committing it, we've already done this in the context of Django. It's the same process here. And again, when I talked about versions, going from development to testing to production, development, testing, staging, production, that's the same thing too. It's moving from one version of the code, which is a set of files and directories that have been saved, moving it to a staging environment, checking out to see if it works, and then moving it on to the final version that you want to save. So this is the workflow. This is the idea. So we're going to skip this add and commit section because these are the steps we're going to go through on where they fit, and we'll go through these commands tons of times. And pushing changes, we're also going to skip that for now because we'll get to that at the end, hopefully. This is the next piece I want to talk about, is conceptualizing this operation of branching and merging. So there's two main operations here that I want to talk about. And this is really fundamental to understanding what Git is doing and how it works. So on this diagram here, we have a line at the bottom with an arrow pointing to the right. So it's going from left to right, which in Western, Indo-European language speaking cultures, again, I can get on a linguistic nerd tangent about why we think of time going from left to right. Doesn't matter. That's what this thing does. And the thing is labeled master. You can see it's labeled master here at the bottom. I want to highlight that now it's going to be called main, because about 10-ish years ago, there was a push to remove this term master because of its association with slavery from all of these things. And so Git now uses main as its default. So you're going to see main as the default main branch of things, but you might see master in the older version. I think Python Anywhere still defaults to master. So we're just going to rename it, which is a handy operation to know how to do. We'll just rename it real fast. But again, when you see master, main is going to be the new term that you're going to run into more often. But this is your main branch. This is the main piece of code, set of code, project. You could think of this over here, if we're over on the left, underneath the word branch, before this arrow and this circle. You could think of us being there. We've written our code. We've got something on this branch, or this main branch. And then we want to develop something new. So let's say, again, I've said, hey, go add a cool feature to this to-do list, make it not a to-do list, make it a food ordering app or whatever. You can now make a branch, which is a copy right here, this first angle off. This feature X branch and the master branch are the same at this point here on the left. Then we can start making changes, doing whatever we want to, feature X branch, and develop all kinds of stuff, and it will not change anything on this master branch right here underneath it, where the two labels are for these branches. So again, think of time moving left to right. If we're not doing anything to change the code on the master branch, it stays the same. And then the feature X, once we've developed it here to the right as much as we want to and it's tested, ready to go, we do what's called a merge operation. And we merge the feature X branch changes we made into our master branch. And everywhere after this merge, on this line, the code is the same. So these things exist as a timeline that when we take snapshots and we do what's called commits, and there's a way of saving, we'll go through that in a second how that works. We just talked about the add, the commit phase. When you make commits, it's points in time along this line that you can roll back to. So if you say develop a feature and you merge it and then it breaks something, you can roll back to before you made the branch if you made a commit back here, or you can roll back to here, or whatever the case may be. Is this making sense, though? The concept of branching, merging, why we would do it. Any questions?
No, I understand why you do it. You never want to work in your quote unquote master branch,
Exactly.
because that's absolute no.
Yep.
But
Yep.
the one fallacy that you have to take into account is when you do a merge, you got to be careful of potential overwrite of code you didn't want to, or breaking code that was working one way, now it's not working because of the new change you put in.
Absolutely. And that's why
So,
testing is so important.
okay, so it's
Yeah.
test somewhere in that merge.
Yes.
There should be, after code's compiled, testing, but GitHub is then linked to a different tool for that, correct? Like
Absolutely. And
Jenkins or
that's,
something. Okay.
yeah. So that's the thing, is where Git won't provide any way to do testing for you.
It's just a repository of the code.
That's it. Yeah. So you can develop something in feature X and then merge it here and break your code base. Absolutely, like you said, it's nothing in here is going to stop you from doing that. Um,
So in
we,
our, just to cut, not cut you off, but
yeah,
the way we did things with my site, we could have set um, different branches off of to do and some of the other code we touched with,
yep,
and then merged it back into the master, correct?
absolutely. And if we
Yeah.
were doing again, if we were doing this righteously from a real project standpoint, we wouldn't have done anything without a Git repository. And every change we made would have been on a new branch that we merged into a main branch. So yeah, 100%. That's
And I might be
100%.
getting ahead of myself, but each time you merge into master,
Yeah.
the version number changes so that if there is a problem, you can go backwards. I think
That
that's built into Git, right?
right. That is again an organizational decision and Git allows you to do it.
Okay.
So yeah, you generally speaking, the way you're going to set up like a typical workflow, you're going to have like your main branch, and then you're going to have a development branch, and you only work off of you pull and make feature branches like this off of that development branch, and then push it back into that, do a whole bunch of testing, then make a version branch, and there's it becomes a lot more than this. This is an ultra simplified explanation just to show what branching and merging is. But yeah,
Yep.
in real life, you're absolutely going to do what you're saying. You're going to have version numbers. You're going to increase that by one when you merge things, and you're going to be really organized in how you do it. But the technology of Git is what facilitates an organization to do that. But it's up to you to design the system that you're going to use Git in, because it doesn't force you to do it any particular way. Does that make sense?
Yes.
Nice, nice, good question. And again, I remember that you had some experience on this at this end of it, project level stuff of this working with Git and using this
My
kind of thing. So
experience
yeah,
has been managing the system and
exactly. Yeah,
designing or setting up the process.
yeah, yeah. So you know
Uh,
exactly what I'm talking about. Yeah, yeah.
yeah, I just
Cool.
don't know how to use it.
Nice, nice. So you will today, and then there you go. So then you'll be able to marry those two things together and make like probably way better Git workflows than I ever have, because you understand the process end of it at the level that you, which is great. So this is the nuts and bolts of it. This is basic branching and merging, and we're going to go through these steps to get hands on with it. And once you do this a bunch of times, it really it really becomes cemented, because this is something that you do over and over and over again. You do it in small chunks so that it's easy to roll back if you need to. And this is great. This has all the commands right here. If you're forgetting the commands that we do, that's why I didn't send out documentation, because you really already have it. We're just going to do this stuff today. So this has more than we're going to do. This promise not to be deep. We're not going to really get into updating. We'll do merges, but there's a lot more going on here. Tagging, this is kind of what you were talking about, Mike, with how you set versions. So when you set the version number, it's typical to put in a tag, right? We're not going to do all that. We'll talk about log a little bit, but this is a great tool for getting going and learning the nuts and bolts. And this PDF here on the side is another really excellent way to look at that same page we're just looking at, except it has the commands written out next to it, like in the diagram, right? Where it says create new branch, but then here's the command itself. So if you forget the command, and it's this marries it together. So this is really good documentation for Git operations as they're used. Um, cool. So let's go and get our hands on Git. To do that, we're going to go into our console. So we're going to go back to Python Anywhere, where we've been several times, and we're going to go into a bash console. And to get started, and again, as a call out, anybody that did not do the pre work of setting up your SSH key, that's fine. You don't have to. That's for later. This piece now is just going to be in local environments. We're not going to be connecting with GitHub. That's for if we got time at the end of class, which I think we should. But I want to focus more on Git itself to make sure we're clear on the merging and whatnot, and then we can just highlight if we don't get hands on with the other parts. So we're gonna start. We're gonna start the way we have any other day, because we are going to work with that project, the code base that we have, right? Our my site project that we made, and do this in somewhat backwards order, but a somewhat real way of doing it, to show where it would fit into our project and what we're going to do. So we're going to go through the same steps. We're going to activate our virtual environment. So I'm going to do source, name of my virtual environment bin, activate, and then I'm going to change directory into my top level my site directory, because that is where we want to put our Git repository, which will itself be a directory. So we want it to be in the same level as our project directory. So what we're going to do first is we're just going to see that we have Git on our system. So I'm going to do git dash dash version, which again, the two flag, the dash dash version thing is handy for all kinds of stuff to make sure you have it installed already. If you don't, which I know you will in Python Anywhere, But there's the version, right? So we have it. We got it ready to rock. The first thing that y'all are going to want to do, if you haven't done anything with Git before, if you haven't done any of these merges and commits and things like that we talked about here in Python Anywhere, you're going to want to set your username and your email because it's going to ask you for that when you go to commit something. I've already set mine, so I'm not going to reset them, but I'll show you the commands, right? So you're going to do git config dash dash global, and then you're going to do user dot name, and then give it whatever username you like as a string with double quotation marks. I'm not going to reset mine, so I'm not going to hit enter on this, but this is the command that you should run. So git config dash dash global, put in a username, and this is going to be for when we go and set our commits. It's going to ask, if you don't do this, it'll say, who are you? What are you doing this for? And then once you've done that, you've set your username, you do the same thing with an email. So you're going to do git config. You could just press up if you did the last one. I'm going to rewrite it. Git config dash dash global. Same thing, but then you're going to do user dot email. So you can just hit up, take off the username part and do email, and then put an email address. I don't think it needs to be in quotation marks, but I also don't think it'll break it. So, similar thing. Set your username, set your user.email. And then once you have those, you should be able to do all the things that we're going to do with Git and hopefully not have any errors thrown at you. All right, so the first thing we're going to do is just try running a Git command here. Since we know we have it installed, I'm going to do git status. This should show us the status of our Git repository. And when I do this, it's going to be like, womp, not a Git repository. So it's not working. We don't have one. So what we need to do is we need to initialize a Git repository. So I'm going to clear that up, and I'm going to do the first command, which is git init, short for initialize. And that's just how we set up our first repository and make it do what it needs to do. So it says initialized empty Git repository in, and it shows you the directory that it's in. And you notice that the name of the directory here is down on another line for me, but it's just going to be a /home /your username /mysite .git. So there is a Git directory in here. You can go look inside of it if you like to. There's usually not a reason to, but now we can do a whole bunch of stuff with it because we have a Git repository now. So now if I type git status, it's going to give me this little output. Let me maybe zoom out a little bit so it fits better. Try that. Not sure that's much better, but it'll say here, so I did git status and it says on branch master, no commits yet, and then untracked files. And then it shows me this whole list of files and directories. So you notice we got this db.sqlite3. Anybody remember what that is? In our directory structure, what that db.sqlite3 is?
Isn't that the database?
Yes, that is our development database. So when we talk about our versions, this is not fit for production version, but it comes standard. This is not typically the kind of thing that we want to include in a Git repository. So before we do our adding operations and commit anything, we'll walk through those in a minute. What we want to add to our project is called a git. It's called a .git ignore file. I sent this out earlier. It's in the Discord channel. If anybody needs it, I can copy and paste it straight over into Zoom as well. Because all I'm going to do is I'm going to take this, I'm going to copy it. I'm going to take the contents out of this. I'm going to copy this stuff, and I'm going to paste it in to a file in our file structure, a .git ignore file in our file structure. This is one from one of my projects, so some of the stuff at the bottom might be specific to my project, but everything from this .pyr thing all the way up, this is like boilerplate stuff for a Python project. So you'll notice it's got PyCache things in here. There's going to be some .env stuff in here. It's basically all the stuff that you do not want to put up into a version control system. So I'm going to take all this stuff, I'm going to copy it. And again, I'm going to do it just for expedience so nobody has to go look it up. I'm going to put it in the chat so y'all can just copy and paste it from there too, if you like. Oh, maybe I'm not. I guess it's 15 more characters than I'm allowed to put in. Here, let me take off some of the extra stuff at the back. Oh no, it's a lot more characters I'm allowed to put in. Here. Okay, I'll put the link to the thing then. In case anybody needs the actual link. I can't put the whole code in, but there's the link to the doc in case you need it. There we go. All right, so I'm going to copy this over. I'm going to go back into my Python Anywhere. I'm going to just put it in using V. So I'm going to clear this up so I got some more space. And I'm just going to use, hopefully folks don't get stuck. Try to stay with me now, but I'm going to use V. You can do this in GUI if you like. But I'm just going to do V and then dot git ignore. All one word. Make sure you spell it correctly. So GITIGNORE, starting with a dot. No file extension. I'm going to hit enter. It's going to say new file, dot git ignore. Down here at the bottom, I'm going to press I to enter insert mode. And then I'm going to hit Control. I'm going to hold down Shift and hit V because that's what you should do in consoles. I think you can do it without doing that here. Actually, it doesn't work here. Now you got to just do Control Paste. So in a regular console, you have to do Shift. Here, you don't have to do a Shift. Just Control Paste. And that should work. So Control V to paste. I'm going to hit Escape. And I'm going to do colon. Down here at the bottom, the insert disappeared. This kind of edit thing might be in the way. I can't get that much better for you. I'm going to do colon WQ, lowercase, to do write, which is save, and then quit as one command. When I hit enter, that should have saved it. I'm just going to do a ls.lha. Oh, that's terrible. No, sorry. ls-a. There we go. And now we can see our .git ignore here. Here's our .git file. So we have our git ignore file. And now if I run git status, you'll see that the SQLite 3, the db.sqlite 3 is no longer listed because that's definitely something that's in our git ignore is something that should be ignored. And our .git ignore is listed in our untracked files. So now what we want to do is we want to save this project in some way how it is, right? So we've got our git ignore in there. That's a key first thing before you do any commits or save anything. And we still, if I scroll up just a little bit, it says no commits yet. So we haven't committed anything yet. So let's do a commit. I'm going to clear this up and do our first command. So we're going to do git add, and we could do period and just add everything. But for our first one, I want to do just the one file, the git ignore. And I use tab complete at this point to enter. So I'm going to do git add dot git ignore. So add space dot git ignore. I'm going to add just that file. It won't say anything happened at all. So if I want to see the status, I'll do git status again. And now I'll see at the top where it says changes to be committed. New file, git.ignore. Everything else is still red. It says not added. Right? So if I commit now, it's only going to save this one that's staged. So if you think back to that image that we showed with the working directory, staging, now our git.ignore is in the staging area. It's out of the working directory into the staging area, right? So we can commit this. So what I'm going to do, I'm going to clear this up again just so we got some more things reading. We're going to do git commit -m. The M flag is for message. If you just do git commit, it'll take you to a new screen and make you put in a message, and that's annoying. So I like adding the M flag here and just put a string in with a message of some sort. And the normal first one is just called initial commit, and that's usually the first commit you put in. And this one will typically, when you start a project, Mike, this goes to your earlier question, this is usually the first step of a project, right? You put in your git ignore, you put in like a readme, maybe, you put in, a license. We'll talk about those things that are kind of the standard beginning files for any project. And you'll do this initial commit with those things in there with no actual code in your code base, like no working code, no Django files, anything like that, usually. So when we do this, it's going to say, all right, master, root committed. We got this big number right here. This is the ID of the commit that we just made. So if we want to go back to it, we can. It says initial commit, one file changed, however many insertions we're in. And then it tells you exactly what it did. So it created that. So now what we can do is we can add everything else if we like. But let's have a look at our log first. So I'm going to do log. Whoops. Not log by itself. I have to do git log. I don't know how to forget we're working with git, and I don't put git first. So git log. And this is going to show you the full commit hash that you can go to. There was an abridged version that came up before. Here's where it says the head is, and it's pointed to which branch we're on, which is the master branch. And then it has the author, the time, and then whatever commit message we put in. And that is our log right now. It has the history of our initial commit. So let's add everything else, just to go through that process of adding everything and getting it ready. So we'll do git add period, and that'll add everything else that wasn't added before. And this will take a second because it's going through all of our project files and directories. Now, if we want to look, it's going to be a lot of output, but I'm going to go through and scroll to the top. So we hit git status, and this is going to list everything. So this should list absolutely everything that's in here. I'm going to scroll up to the top of where I called the command, where it says on branch master changes to be committed. And I'm going to double check that our .env file was not grabbed, that it was in our ignore. And if you recall, it's in my site. And so we're looking up here and we don't see the my site /env. So it was in fact also ignored, which is good because that may have sensitive information you do not want to push to your version control. So that's one of the reasons we do our git ignore before we do the rest of the files. But now we can put the rest of the files in there. But if you're looking through this and you're like, oh, wait, no, I don't want this one to get saved in there, or whatever the case is. If you see something in here you don't want to be saved, you don't want to get pushed into your commit, not committed, you can use this command right here, git restore, to pull something out and call that file back out and unstage it. But it'll remind you each time when you do this. So again, this is when we do git add, this is just like the Django make migrations, where we now get to look at everything that's going to get committed to our timeline and make sure that we only get the right stuff. But this is not a test. This is not testing that our code works. We could push broken code into our commit. Am I tracking? All right. So testing is separate. But what we're going to do is we've added everything. I'm going to clear this up so I have a cleaner screen. And we are going to do our commit. So we do git commit-m. So we put in some sort of message. And then we do something descriptive that are, this will be kind of organizationally dependent, but you at least want to put something that you can recognize later as an important piece of this. So you could just do added project files, whatever it is that makes sense to you for your project, following the conventions of the organization you're in. It'll give you this long output of everything that was added and updated and what it did. Clear this up. And if I do git log -- this handy flag called one line, will give us a log that's a little bit more compact. So it doesn't show the author, the date, but it does show the ID of the commit that you did. It shows where the head is, which branch is the latest, where the master branch is. And then it says added project files. So this is the latest commit. And this is the note that we put on it. Here's our initial commit. So now we can see that we are building this timeline. And that if we wanted to roll back to a further, a time before this, if we're like, oh, wait, we didn't want to add all those things, we can now go back to this commit and it'll take all that. It'll be as if that never happened. Making sense? Any questions about this? Because that is the basic steps of just doing commits and adding things and making changes, right? So there's the first steps that we need to do to set up our repository, make some basic changes, make some saves. Now, the other operations that we definitely need to work on are the branching and merging. So let's go through that, right? So now we've got ourselves set up. We have our initial commit ready to go. We did another commit after that to put our project files in there. So now let's change something. Let's make a branch, do some kind of change, and show what those branching and merging activation features are like, right? So let's imagine we have a scenario. We're going to make a new feature. What we're going to do first is just to see what branches we have. We're going to do git branch and have a look at it. So we do git branch, and this will list all the branches we have. The one you're currently on will be highlighted green, and it'll have a little asterisk next to it. All other branches will be listed in white. But you see, we still have our master branch. So we want to change this. And I believe I have the renaming name. I think it's branch as well. So what we're going to do is do the name. So git branch is also what we do to rename things, right? So we have a name master we don't want, and we're going to use the M flag, which means different things in different places. In this case, it's going to rename the master branch to whatever we want it to be, right? So we'll give the name of the branch we have, so master, and then we'll just put main. So we'll say get branch dash m master main. And as you can see, this little, I didn't highlight this before, but the name of the branch you're on is printed out to your console in this other set of parentheses, right? So we have our virtual environment over here in white in parentheses, and here in yellow or gold in parentheses, the name of the branch we're on. So it changed from master to main. But now again, to confirm, if I just do get branch by itself, it'll list out we have a main branch, not a master branch. All right. So that's renaming branches. That's how we change the name of a branch. But now we have our main branch. Let's make a new branch to make some changes to it and mess around with things. So to do that, unfortunately, we don't use a branch command. We're going to use get checkout. And checkout is how you move between branches. It's how you tell it to check out one set of code and start working on it. This is like change directory, but think about it through time or dimensions or something like that. So we're going to check out. And it's, since we're making a new branch, we're going to give it a B flag to say checkout. And this is telling it a branch that does not exist. And we're going to give it a branch name. So we can give it, this is an arbitrary name. You can come up with literally anything you want to. This is going to follow, again, conventions depending on what point of the process you're in and where you're working and all those sorts of things. So we can just do feature-x like in the documentation. If you want this to be modeled off a specific branch that already exists, like this is just going to go from the main branch because that's the only branch we have. But if you have several branches and you want to make like a copy of a specific one, you could then put that name of the branch in after it. Like if I wanted to say specify to copy the main branch, I would put that branch name here. But we don't need that. It'll default to copying the branch you are currently on if you use this construction right here. So get checkout dash B, name of the feature you want to do. And it'll say switch to new branch feature X, and you see it updated that as well here, which that may not be standard when you set this up on your own device. This little piece here is something a Python Anywhere set up in our console. That's an optional thing to do, but it does help us out. It's handy. So now what we can do is we're on this branch, right? So if we do get branch, again, we confirm that we are on our feature X branch. And if we do get status, it'll say on branch feature X, nothing to commit, working tree clean. That means there's no changes. We haven't done anything. So let's do something. Let's make a change. This is just going to be an arbitrary change to our code. So I'm going to open up a file, make a quick change, save it. It doesn't really matter what, but I'm just going to do our base.html. Just going to open up using V, do templates, base.html. And I'm going to hit I at wherever I am. It really doesn't matter. I happen to be at this div at the end of my end block, and I'm just going to add something new here. Totally arbitrary change. I'm going to add a p tag. It just says I'm new. And I'll close it up, right? You can put literally anything. This is just to show that we are changing something. So I'm going to exit insert mode by hitting escape, then colon WQ to W stands for write, Q stands for quit to save and exit. And now if I do get status, it will say that this file was modified. So what we're going to do is go through and add it, commit it, and do the things that we've done before and save this to our feature X branch. So we're going to do clear. So we're going to do add, and I'm going to do add all because I know it's everything that we did. Whoop. Get add. Good God. How do we forget get on get day? So get add all with the dot stands for all. And then we're just going to do get commit dash M. And then I'll say updated, doesn't matter, copy. So again, something that's descriptive of the change that we made. Don't have to say the file because it'll say that in the history and all those sorts of things, and we can look that up later. And this will tell you exactly what it was. And so now if we do, let's just do git log one line again to see what it looks like. So now we can see that here is the hash of that commit that we just made. And we have our head. So this, again, this is the now. This is where we're looking right now. This is where we are. We're looking at it now. Feature X, we have updated copy. So it's ahead of our main. Here's main labeled here. Our main is still back here, right? So it's like further back in time, but they both exist right now. And on our feature X branch, it's a full copy of our site. Our site is still going to run. If we go and, refresh the code on the server side, do all those things, the site will run with that new little piece that we added on there. I'm not going to demonstrate right now. You can go look if you like, but in the essence of time, we won't. We're just going to say that it's there, and we can show it by saying, here, I'm going to clear up my screen a little bit. I'm going to do clear. I'm going to use the concatenate and just print out that file that we changed. So I'm going to concatenate template base.html. And you can see right here, here's the I'm new piece that I added. And I'm on the feature X branch. So I'm going to leave this up. because we can scroll up and look at it again. But I'm going to do get checkout main. And this is how I switch back to my main branch from my feature X branch, right? So I've already committed this change. I've done what we needed to do. So I'm going to go get checkout main. And now I'll switch the branch to main. Now, if I do that same cat command, cat print out my templates based on HTML, here's that div and here's my script. It does not have, I'll scroll up here. It does not have this I'm new paragraph. So here's that div, here's the script. This is from the feature X. It does not exist. So now again, if we went and looked at the site, reloaded the server-side code, did all those things, it would not be there. But these both exist at the same time, right? So it's two versions of our code. They exist at the same time. It's almost in like multiple different dimensions. One has this paragraph in it, one does not. Does it make sense? All right. So now what we need to do is let's imagine that this is the most wonderful change and we've updated things exactly how I want them to. It's all beautiful and perfect. So we need to pull it into our, well, not pull it, sorry. I don't want to say pull because that's a different terminology in Git. We want to merge these two together. So we need to merge in the changes that we've made from the branch that we made them. So now we're going to simply do get, here, I'm going to clear up my screen so we don't have all this stuff on here. I'm going to do get merge because again, I'm on my main branch. So if I wasn't, I would want to go to the branch to which I want to merge things. I want to be on that branch. I'm going to get merge and then the name of the branch that I want to merge into the branch that I'm on. So get merge and then feature X. When I hit enter, it's going to say fast forward mode. And there are ways to skip this. And actually a kind of a best practice I probably should have mentioned is the no fast forward flag. This is something we actually usually use because then it creates sort of a easier way to go back in time that's a little less destructive. But the merge operation doesn't require that. This is the basic command that you need is the one that we ran with just the merge and the name of the branch that you have. And it'll say fast forward. This is one of the merging strategies. We will not get into depth on what that means. I encourage you to look it up if you're interested. But generally speaking, it's kind of an overriding, heavy-handed way of merging your changes. You can skip the fast forward by doing the no fast forward flag for somewhat cleaner history of things is about the short answer I can give. But now we're still on our main branch. And if we concatenate that templates based on HTML, we do have our paragraph there. Our new paragraph is there. And if we check our get branch, we still have our feature X branch. It still exists. It's now just going to be paired. It's going to have parity. It's going to be exactly the same as what's on our main branch. So if I do get log -- one line, you'll see that all three of those things are stacked up, right? We have the same hash as the commit when feature X was ahead of main and head was pointed to feature X. But now main is also in the same spot. So head is pointed to main and feature X, and it says updated copy, and it's got the same hash as this. So this is what happens when we did the fast forward merge. It merged everything up into one spot, and there's one line of history to go back through. And if we did no fast forward, it would be a slightly different looking merge, but this is the basic merge process. Is this making sense? Anybody got questions about this? All right. Like I said, man, there's the last chance to ask questions. If you don't ask now, no, definitely not. It's something that just, these operations specifically with just doing it locally here. I really recommend it for anything you're doing, any coding. Doesn't have to be Python. Doesn't have to be, like literally anything. Doesn't even have to be coding. I mean, you could use this to keep track of documents, just regular text documents if you wanted to, and make it almost like a Google Docs kind of thing where you can collaborate with people without working through Google Docs, But the other piece of this, now we've done all those local operations. This is great. And this is something that I really do encourage everyone to do with their projects. But the other thing that's great about version control systems is the ability to collaborate with other people and or save things online into a repository. So we're going to go through some things on GitHub now. We'll go over to GitHub and have a look at that. So if you set up those things with SSH key ahead of time, please follow along and do these. I'm going to show you how to interact with other people's code and pull it down and talk about it a little bit more. And we'll go through hands-on how to do it. If you haven't, that's fine. You just watch and do this later. That's totally cool too. Ask questions and understand the concepts is really the important part. And also keep in mind that everything we're doing with the merging and the branching and the pull requests and all the things that we're about to do through GitHub, again, do not require GitHub. This is things you can just do with Git. GitHub is one of the places that is an online repository that you can put, or an online service that you could put your repositories. So we're going to go over to GitHub. And in GitHub, I'm on our Hired Labs organizational page. We've got a couple of different things on here. This is generally the layout of GitHub, kind of all the way around. We have a list of different repositories. And anything that is available and open to the public is something that you can click around and go into, right? So open source things like us, you can go in and read the source code. So I'm going to go into our bootcamp poker game repository. And anybody that wants to follow along at home, I'm going to drop this into the chat, the URL to this. You're welcome to check it out as well and do this with me. And I encourage you to do it. But the thing that is so cool about GitHub is that anything, again, that is open source code, and what I mean by open source is that this source code itself is available, you can go and read it. So right here we have a very simple, this is a poker game that you know, I whipped up to mess around with at some point when I was doing something and decided to use it for this class as an example of Git. And it has, you know, it's just a Python, it's written in pure Python. Git will tell you what languages are used over here on the right-hand side, right? So there's some information about releases, if you have any, if this project is that thorough, you know, packages, if it's something that comes out like that. This is very simple. It doesn't have any of that. But it'll have, you know, a license. This has, I always put a license on it. So this is where it will decide whether or not it is open source, how you use it, what you're allowed to use. Most of the things that I use, all the stuff that Hired Labs uses, this is all open source. You can use all of our stuff. And this is also where you can see if you contribute to one of these projects, which I'm going to show you how to do, and I'm going to encourage you to do that with these projects, because when you do, if you're trying to actually become a professional developer, this is one of the places that people look for your portfolios, your interactions with other people on these things in projects, like, you know, doing what we're about to do. It'll put your little picture over on the side if you commit a change to this project, and it'll say you're a contributor to this project. So this is a really, really cool website to just do that sort of thing, the interactions we're about to walk through, but also just to see the code and read it and practice. So like I clicked on the main.py file and we can just see the actual code, just right here. We can read it. So this is an excellent training tool for when you're getting going, just to read other people's code. It's really, really, really handy to see how it works. And you can mess around with it, right? So you can copy just one individual file. You can do all sorts of things, but I'm going to show you how to pull this down, copy the whole thing, and run the entire program on your local machine. We'll go through making changes and sending them back up as well as a process. But this, again, if you keep in mind that anything that is open source, that you can get access to the source code, you can do a similar process and run that code on your machine. So that's what's so great about these things. So let's go through that process. We're going to do this bootcamp poker game as an example of how to do it. So there are a couple of ways that you can get code from GitHub and interact with it and do things with it. So there's this big green button here that says code, and we'll go to that in a minute. But this is going to do what's called a clone. And we'll talk about that soon. This is where the SSH thing is good to be set up. But this is typically if you just want to take somebody's code and just run it, or if you're inside of an organization, like say you work here at Hired Labs or something like that, and you have access to the organization, you might be able to just clone things directly and then send changes up that way. But if you're intending to contribute back changes, you're not going to want to clone it directly. You're going to want to what's called fork it first. You're going to fork it first. So what we're going to do in this class now is we're going to fork this repository, and then we're going to clone it. And I want to make sure that I'm clear on what the differences are, because they're very similar. If both of them are making copies of the code base, but when we fork it, we're going to make a copy from here to our GitHub account, our personal GitHub account, from wherever this came from. And then we will clone it down to our personal machines. So cloning is copying down your machine. You can skip the fork if you don't want to send it back up. That's a step that, again, once we do a pull request, I'll show you what that is. Forking is the first step that you're going to want to do if you're not a part of that organization. So that's why we're forking. But we'll clone as well. So we're going to go up to fork. And again, let me pause there. Anybody unclear on what it is we're about to do before we get started? Any questions about that? Did I just muddy the waters by trying to explain the difference? Okay. All right. So we go.
Good.
What's that?
I think we're good.
Okay, cool. So we go up to fork, and it'll say existing forks. You can't make another. I mean, you can. You don't have to call it something else, but it'll tell you if you've already forked this repository, right? So if you open this up and it says you have, then go look in your repository list. But since I don't have one, I'm going to say create a new fork, or I just click on the fork button if you like. It'll take me to this page where this is what you're going to get when you create a repository of any kind. If you do it through GitHub instead of doing it the way we did through the console, it'll look pretty much like this, where you'll have an owner to choose. If you're a part of different organizations, you could have a drop down. It's probably just going to have one if you just have your username. And then you can name it whatever you like. I'm going to keep it like this because it tells me that this is available, meaning that in my own sets of repositories, there is no bootcamp poker game repository. I can add a description if I wanted to. And then it says, it said a little note about contribute back to the Hired Labs Bootcamp poker game by adding to your own branch, and it has learn more. So if you want to learn how to contribute back, this is a good place to do it. It's got documentation on that, but we're gonna go through that. It's called through a pull request where it says copy the main branch only. We'll leave that checked for now because I don't think there are other branches of this. But this is if there are several branches. There may be a number of branches on any given repository. The main one, again, though, by default, that's going to be the main one. You should probably just fork that. So I'm going to hit create fork. It didn't change any of the default settings. And then when I do that, it's going to say forking. Should only take a few seconds. And I now have a copy of that code in my own personal profile. So this is now mine. This code is no longer directly linked. It is linked, but this is my version of it, right? So I could do stuff to this, and it's not going to change. It's not going to change that. We're going to make our own branch and do some other things. But now you can see that there's some different buttons up here at the top where it says this branch is up to date with, and it says the source branch that it's up to date with. There's a way to contribute, which we'll get to. Says no commits yet. Enjoy your day. We'll mess with that. There's a sync, so we can update it in case changes have been made on that side. But now that we've done this, now that we've forked it, what we want to do is we want to set it up on our side. We want to be able to set it up in our Python Anywhere and run this code, right? So we forked it here. We have our own version ready to go. Now we're going to clone it. So I'm going to go to this big green code button. And again, we could have skipped the fork if you just want to run somebody's code. You don't want to contribute back, but the forking was required to contribute. So we're going to go to SSH. There are HTTP and GitHub CLI options to do this, and you're welcome to try those out at your leisure. SSH is very common. It's the default. It's what we're going to do here. It did require that setup beforehand if you were able to. If not, then you can try HTTPS, give it a shot. This is being deprecated from what I understand, so it may just not work. But if it's still there, again, you give it a chance. So SSH, I have that set up. I'm going to do that. And we're just going to copy this whole thing. I'm going to click this little copy to clipboard. Copy this whole thing right here. And we're going to go back to our console, to our bash console. And since we're going to be doing a different project, I'm going to get out of my site project, out of this Git repository, right? So the way we do that first is I'm going to clear this up. I'm going to deactivate first my virtual environment. So I'm going to type in the word deactivate, and that should take away the virtual environment tag from there. So now I just have the console back. And then I'm going to change directories out of my project directory just by hitting CD and nothing else. It'll take me by default back to my tilde, which, if you recall, is our /home/username directory. And you see that when I did that, all I did was change directories. I didn't do any other special commands. But as soon as I moved out of a directory that is part of my Git repository, I'm no longer in that Git repository. So if I do git status, this will tell me again, not a Git repository. So now that I'm here, I'm outside of a Git repository, but I still have Git available to me. It still exists. I have it in my system. I'm just not in my repository now. So I'm back at my total starting point. This is like before we started our day with the project. Now we're going to be running a new, different project, right? So if we're doing this righteously, we'd set up another virtual environment for it. We're not going to do all that. We're just going to get the Git repository and pull it down and see how it goes. So we're going to do git clone, and then, I forgot that Python Anywhere copies everything I highlight. So I have to go back and copy this again, and I'm going to paste in after git clone that thing that I copied from GitHub, right? So it's going to be git@github.com, and then the username / name of the repository.git. And it's going to ask for this passkey because I set one up. See if I remember my passkey. Don't look at my secret code. Okay. So now we have it done. We have checked in our stuff. Now if I do clear and if I do ls, I'm going to have this bootcamp poker game directory now, which I didn't have before, right? And so I can CD into that bootcamp poker game. And now you can see it popped up with this main again. So now I'm in a Git repository once again, and I'm on the main branch. And if I do ls, it should have a license readme and a main.py, just like it does in here. You see, it doesn't have a git ignore. Well, actually, no, hold on, it does. ls. Boom, does have the git ignore. I forgot the A flag. So it's got the git ignore. So it's already in there. So we don't have to add that. That's already part of the repository. It goes up and down with the repository. So it doesn't need to be added to or changed. And so we're good to go. So now what we can do, now we have this, we don't have to do anything else. Well, let me clear this up. So I can just do Python 3 main.py like we did early on to run our thing here. And it'll take me directly into this. So this is, a simple Texas Hold'em game. We're not going to go through all of it. But this is pure Python. These are just Python classes and operations and whatnot. Here, I got to zoom out or else we can't see this. But so what this does is it just has some like AI players and it deals out some cards. I got a 4 of spades and a 3 of hearts. And, it asks me what I want to do and it goes through some different things. So we could play a hand, we can fold or bet or whatever. And there's different mechanics through this and the action moves forward and we can do all that sort of stuff. The point is in the game or what it does. I encourage you again to run this, pull it down and get it to operate. The idea was that we could go to GitHub, we could get the code, and now we can run that full program here on our own machine. And we have access to the code ourselves. So we can do what we like to this, and it's our own version of it. And we have it locally. And we can do this with literally any piece of software that's open source that's available on GitHub. And there's some really cool things out there. There's, all kinds of different, anything you can imagine, really. There's probably an open source version of it, right? So anything from video editing softwares to AI models and all that kind of stuff. Just, keep in mind some of that takes a lot of memory to run on your machine. It might take up some space. Like AI stuff takes up a ton of space. Machine learning stuff usually takes up a lot of space. But you can go pull those things down in the same mechanics that we just did with the clone using Git and run other people's code on your local machine. That making sense how we did that up to this point? Nice. So again, the poker game, if you actually play with it, it is all kinds of buggy, had all kinds of issues with it. It's not actually legit in a lot of ways. It does some cool mechanics. There's some cool stuff in there, but it's not like, it just picks a winner at random. It doesn't actually matter what the cards are. There's a whole mess of things that are wrong with it. So I really do encourage you to pull this down, use it as a practice tool, make some changes and send it back. And we're going to go through those mechanics now of how you would do that. And I want you to see this as something that you should feel comfortable messing around with. You know me, you know us. It's not going to be something that we're going to reject you. But this is the process that you should be going through to establish a portfolio, work with other people, do all these kinds of things, right? So we're going to go through sending a change back. So we're going to make a change real quick, and then we'll send it back. So I'm going to do this. I should do it in a separate branch, but we're going to skip that. It's a best practice to make a new branch and do all these things through all those pieces. But we're going to kind of skip that and just do a change real fast and then just push it up in a pull request and rock it off the main branch. But I am telling you, go through the branching like we did before, go through those steps, make a new branch, do the whole thing, the whole pushing it up the way we're supposed to. But we're going to go through the commands of this real fast. First, I'm going to have to make some kind of change on this. So I'm going to do, what do I want to change? I'll just change the README file. I'll make some kind of change to the README. And this is also, again, something as of note. If you're going out into the world of programming and you want to start working on other people's projects and stuff like that, adjusting any document is a really good way to get through this, right? You don't have to do some sort of crazy core stuff. Updating the README documents and those sorts of things, that's a valuable thing for people, right? So if you want to dip your toes into this interaction with unfamiliar projects, you can start with the README files, see if they're accurate, check them out, do that kind of thing, right? So I'm going to make a change here just to make a change and show the mechanics. I'm going to enter insert mode again. And instead of just calling this a poker game, we'll call it Texas Hold'em. There we go. And say we're satisfied with all those. So I'm going to do escape to get out of insert mode and then :WQ to save my changes to my README. And now if I do get status, it's going to say that my branch is currently up to date with origin main. So this is a new piece of information. Origin is the place that we pulled it down from. That's the remote repository up on GitHub. That's what it's called, origin. That's the origin that we pulled from, right? And we're currently up to date with it because we haven't done any commits yet, but we made a change. So let's add that. So do git add everything. I'm gonna do git commit dash M, and then a string to say updated title, whatever, in the README. Clear this up so we have more space. And if I do git status, it'll say on branch main, your branch is ahead of origin main by one commit. So it says git push to publish your local commits. So that's what we're going to do. So we're going to do git push. The push command pushes it up to your repository on your profile that you pulled it down from. That's what origin is from before. And so we're going to say git push the place we want to push to, origin, and then which branch we want to push. So we're going to say origin main. If we had made another branch, which again would have been best practice, we make another branch, we could push that branch up and do the same process that way, but we're just going to run through main on this. And you just do the name of the branch you want to push. So we're going to git push origin main. It's going to ask for this again for me. Again, don't look at my secret code. Okay. And then once we've done that and we've passed our security checks, it'll give us information about what it did, and it'll say, cool, we did this update of main on from your local thing to main up on the GitHub repository. So now if I go back on here, I haven't refreshed my browser yet, but if I go back to this GitHub page where it says this branch is up to date with the main branch that we pulled it from, if I hit refresh, should come up and say this branch is one commit ahead of this. So now if I click on this contribute button, what I can do, since it's ahead, one commit of the source, this big green thing popped up here that says open pull request. And this again may seem counterintuitive why it's pull. Like it seems like pull should be coming towards you, but we think about it from the perspective of the main repository. We are requesting that the owner of the repository pull our changes into the main repository. So that's why it's called a pull request. We are asking them to pull it, not us. So that confused the hell out of me when I was first learning this. Like, why is this called a pull request? So pull request is from their perspective. So we're going to open a pull request. And it'll do some automatic checks. And again, this is all things that can be done through, this did not have to go through GitHub. This is not a GitHub specific. This is a Git thing that we're doing here, but we're doing it through the GitHub UI because, again, this is a very common way to do it. It'll help you collaborate with other people. So it's going to automatically compare changes. It's going to say, okay, cool. Are we able to merge? What it's looking for is conflicts. If there are conflicts in the merge, you're going to have to resolve those at some point, probably before you send this over is a good time to do that. So this is going to give you a chance to do more of those things. You see that it defaulted to whatever commit message I put in before, but I can add more stuff. I can write lengthier descriptions. If I scroll down here, it shows the specific changes, right? So there, here on the left side is what there was, and it says minus, and it's in red. And then here on the right side is what there is, what was added, what was changed. So this right here, again, you can run this locally. You can just do git diff, and it shows the differences between branches, between files. But this is a place you can look before you move on and ask for the pull request to go forward, right? So now I've done that. I'm going to do the create pull request right here in this green button once I'm satisfied with all the information I've put into it. I'm going to create pull request. And it'll say, yeah, I don't know, man. I don't know if I like you. It's going to check again, see if everything works. And then it'll set this up where there is a pull request. So now from my side, from again, if I'm doing this with myself, right? And I can see that someone else did it as well, which is awesome. But now I can go because I'm the owner of this and this is my organization. I'm one of the people that has admin rights here. I can see up at the top bar all my pull requests. So this is, pull request number 7. If I go back here, I can see, again, whoever else is doing this along the way. I like it. I like it. We're updating things with the same stuff. I love it. So here's one that I did, and here's another one. The one of y'all did. And what I can do here now is, again, in any of these, on mine and yours, makes no difference. We can comment through this. I can add a comment. We could talk back and forth. I could just close this. I can say, nah, I don't want it. I can reject it. I can do different merging strategies from here, different ways of merging. We're not going to get into the details of what those are. But once I'm satisfied with it as the code owner of this code base, I can just do merge pull request and it'll accept it in there. And then once I've done that, if you send out a pull request to me and I merge that pull request, you will be counted as a contributor to this project. And people could see the code that you contributed to the project. So I didn't make any changes to it. I updated the commit, and then it'll close automatically, and so it'll just be listed as being pulled into the code. Now we do these same things here. Oh, this one's got conflicts. Probably follow the same thing and change the same thing, so we can't change it twice. But that's basics of the GitHub part of this, the collaborative part of this. That's how you would contribute to a project. Again, coming from the outside, you want to fork it first, then clone it down, make some changes. Again, best practice to make a new branch, send that up, and open a pull request to have it pulled over. Any questions about those operations, that basic Git branching and merging and collaboration? All right. Well, then that is pretty much it. Alex, you're welcome. I'm glad it was helpful. So we got a few more minutes. If anybody's stuck somewhere, absolutely welcome to hang out and get that unstuck. But in terms of where to go from here and next steps, again, you all have the tools and parts and pieces to build pretty much anything you want. Now, if you want to continue to work with web apps, you have a good starting point. You can refine that and make something different. You can use the same principles that we used here to build mobile apps instead of web apps. You can use mobile frameworks for development, like React Native or something like that. And yeah, Alex, make a portfolio. Again, you can use this Python Anywhere site to make your portfolio, and adjusting the to-do list app to become a portfolio. That's a real simple set of changes. You know what I mean? And you've got all the tools and parts and pieces. You've got a starting point with your Git repository if you follow through the first half of class. And so any change you make, you can feel free to make a branch, and then you can just destroy it and get yourself completely stuck where it's broken. And if you maintain your main branch and you do very disciplined branches and commits, you'll maintain a solid set that you come back to that's not broken, and it'll continue to work, and you can just keep building and refining off of that. And also from our side, we will definitely stay in touch with you, not obnoxiously so. And yes, our next class starts April 15th. It's not a different course. It's going to be the same course again. So, if you don't want to sit through the same exact content, that's probably not the move. But you're welcome to come back if you want to come through it again. Some people have done it twice because they felt it was too fast. They wanted a refresher. You are absolutely welcome to. We don't have any next level classes. At some point, we're planning on making those, but we're really focusing on getting more folks through this as we can. But we do have the other side of our business. And Alex, that is a great question, because I was just getting there, and quite literally the other half of our business is exactly what you're asking about. Finding jobs in whatever field you're trying to get into, that hopefully you're fit in some way for this specifically. So there are a number of ways that we do that. The other side of our business, the other service that we provide, is a general resume writing and job search service that's open to all of you. It's open to veterans. You don't have to be in this bootcamp class to do that one. Just two separate things. So if you haven't already been invited, my team will be reaching out to invite you to that as well. And don't even worry about that, Mike. As you say, you code, you have 4 left feet. Don't worry about that. It's not something that you're going to be amazing at right away. It just takes practice. So keep moving your feet, and you'll get better. And absolutely, like, you're putting in the work, you're going to get there. So
I tried to add the SSH key,
yeah.
and it kept saying invalid.
Oh, did you copy everything from that file?
Yes.
And it still wasn't taking it?
I even added the SSH.RSA in quotation marks before it. I
Yeah,
thought
no.
that's what that.
So I thought we had to generate our own key, right?
You do,
That's
yeah. Yeah. We went through that. Me and Mike went through that before class started today. So it should be in here. You have your SSH file.
Yeah.
And then the key should be, if you just copy everything in here.
Oh, that's the key?
Yeah. That's what I'm saying is
file.
Is that sometimes, yeah, like sometimes you'll get some other thing, but this is the file that you need. This is the key. Like, copy this whole thing, including your email address. Put that whole thing into there, and it should work. And then Alex, I see your question in chat. I'm reading it. That was our website. We can access guidance. There's the guidance set up through email. Yes, it's set up through email, right? So again, my team will reach out to folks. If you're really interested to get going, you can reach out to us. You can email me at jeff.stock@higherlabs.org or just info@higherlabs.org and let us know that you're interested in the resume and job search service. And we can set up a time to talk about that. And it'll be, again, not obligated. You don't have to. It's not related to this. You're welcome to take part in that if you like or not. And but yeah, if it's something that sounds good to you and you don't want to just wait around for us to reach out to you, absolutely reach out to us and let us know that you're interested. And we'll put you to the top of the list and get you set up with a time to talk and set you down that road. And for anyone else that's not interested, again, stay in touch on Discord. Stay in touch with there's a whole bunch of vets in there at the same level that know these things the same way you do. That Mike, like you're feeling with the 4 left feet, we all have that feeling. We're all beginners, so stay in touch. Work on projects. Contribute to our project. You're all welcome. I didn't show this, but our actual website and everything that we have, it's open source. It's all open source, right? So we have some tools that do keyword analysis of job posts and things like that. You're welcome to go in there and contribute to that as well and work directly on the core stuff that we have. And we use all the same technologies, plus a few other ones that we didn't cover in this class, but all the same stuff that Django and all that stuff is Python. It's as you can see right here, it's mostly Python that we're writing. So again, stay in touch with us, reach out with questions. I'm Alex, thanks for saying that. I'm glad you enjoyed the course. Please, 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 everybody that's watching this, whether you're watching in the video or you're here live in class, we'll send out a feedback form. Please give us that feedback. I'm going to, putting it here in chat is great. I'm going to take that there. But any way you want to give it to us, even if you're like thinking about it later and you just want to email or, you want to call me and be like, man, that's, well, you led me wrong and now I hate you, whatever. Seriously, feedback is always good. We're a young organization. We thrive off of it. So let us know. But if nothing else, we can wrap there. Again, I'll stop the recording, but I'll still be hanging out if we want to talk about specifics, if you're stuck somewhere. But thank you all very much for your time and attention.
Hey, if it's okay, I'll probably be in touch as I start coding. I'm linked to some of the self-taught courses that you listed.
Yeah.
Those have been pretty good. They're fast, they're quick, but they have been good. And where I make a mistake, I can easily see where the mistake is made and learn from it.
Yeah, I love the free code camp ones. Those were my absolute favorite when I first started because you can really easily fit them into your day. They're broken down in like 15, 20-ish minute increment, bite-sized kind of things that you can work on and make it a daily habit. So I'm glad you like those, man. That's excellent.
I really appreciate all that you've done. You've been a great teacher, and you've been very patient with someone like myself. And I look forward to continuing integrating with you.
Yeah, absolutely, man. I appreciate the effort. Like this, again, I can't make you do the work, right? I can just present this to you and show you where it is. And so if you don't do it, if you don't pick up your feet, like I said at the beginning, man, if you didn't do the push-ups in boot camp, you wouldn't have got through that either. So you're the one doing the work, and I'm genuinely appreciative of that. So as long as you're willing to do it, I'm willing to be there with you. So again, this is the end of the course, but it's not the end of our time together. If you want to stay connected, please, please, please do.
Excellent. Well, appreciate it.
All right, y'all.
Yourself a great weekend then.
Yep. You too.
Much appreciated. Thank you.
Yep. Thank you.
Take care.
You too.
Thank you so much.
Thank you.